Next, let's double check this with StatKey. So we have two ways to do that in StatKey. We can use the normal distribution given our standard error or our z-score, or we can use the randomization. So I think I'll try it both ways for fun. So let's jump over to StatKey. And I think I'll start with the normal distribution version. And with the normal distribution, if you have a z-score for proportions, then you can just use the standard normal, which has a mean of 0 and a standard deviation of 1. So then I just need to get the calculated z-score, and that could be done with a handheld calculator instead of a spreadsheet like this. So you would need to calculate each of the proportions, and then you would need to find the pooled proportion. Once you have the pooled proportion, you can then use the formula for the standard error that I mentioned back here in the notes. And that would be, let's get my highlighter, this formula right here. So you could whip that out on a scientific calculator using the pooled proportion and the two sample sizes. I already did it in the spreadsheet, so I'm just going to go grab the z-score, and I'm going to grab 4 decimal places, so 05663. So in StatKey, I would say I want to do a right tail test here, and I would enter the z-score of 0.553, and this, I missed something, 05663, sorry about that, 663. And the spreadsheet basically does the same thing, but it uses more decimal places. It uses the standard normal to make that calculation. And here I can see I get a p-value of 0.286. Alternatively, you could use the sketch that we made back here and use the difference in proportions from the null hypothesis, 0 in this case, and the standard error that we calculated along with the difference in proportions, right? So that way it's a little bit more work. So I like the z-score version better, but alternatively I could come up here, edit the parameters, mean of 0, standard error of, let's go with 1443, right here, 0.1443. And then to do the test, I would then use the difference in the two proportions. And so that would be this line here. So 0.0817 about. 0.0817. And I should get about the same p-value. Yeah, same p-value. Could also use a randomization distribution. So StatKey, new tab, randomization. For a hypothesis test, I want to test for difference in proportions, and then I need to enter my data, and that was the 12 students who started their homework before the due date out of 23 in the online class and 11 out of 25 in the in-person class. And then StatKey will calculate for us that difference in proportions of about 8%. The null hypothesis is already set for difference in proportion, so then I'm ready to generate. Good enough, 6,000, right tail test. Then I have to enter this difference in proportions down here, 0.082 according to StatKey, and I should get a pretty similar p-value. Ooh, that's a much smaller one, but 20%. Reject the null hypothesis, or fail to reject the null hypothesis. It's in the ballpark. Interesting. I think it's significantly different, 28% versus 20%, because sample sizes of 25 and 23 really aren't that big for a proportion. So we're on the low end of being able to compare the central limit theorem to a randomization. Whenever your sample sizes aren't that big, you're usually better off doing a randomization than you are applying the central limit theorem, which is what the spreadsheet does. Either way, I'm failing to reject the null hypothesis. A proportion of students at 52% versus 44% for sample sizes of 23 and 25. They're not that different. They're close enough. All right, thanks for playing. See you later.